Hi, my name is Razi, and I'll be demonstrating this project that we made for my machine design class. When I say we, I also mean my group members Brian and Aaron. Um, this project demonstrates the concept of force summation vectors, um, summation of force vectors. I'm sorry, and the idea is that you take on a given object, forces acting in different angles in different directions should all come to a total sum of zero. In other words, they should all cancel each other out. For example, we have a weight hanging in straight downward motion here, a downward direction, and we have these two fishing line strings um, that are acting in different angles, and those tensions are equal to these weights hanging from each side. Um, Essentially, this force and this force combined should equal this force, or vice versa. These two should equal that force. Um, and I'm going to go ahead and demonstrate this project really quick. The way it works is by bringing the weight down all the way to the bottom. On these wooden dowels, we've put some Scotch tape, and we've also poured some of this Wall Universal C1 lubricating oil, which is very viscous, great lubrication. And what that has done is essentially given us, I can't say exactly 100% frictionless pulley system here, but it's gotten it's minimized the friction to a great extent. And the way it works is this: you get your weight all the way down, and then you let it go, and you wait till it stabilizes, and that's your equilibrium. And what we're going to do is we're going to use this these two straight edges. It's a simple angle finder usually used for by metal workers when they're welding frames to get the degrees and get the angles just right. And we're going to go ahead and set this up on here to first string, and that comes to an angle total of 29 degrees, and this one right here comes to 30 degrees. So we've gotten this down to plus or minus 5% error. By our calculations, we got 4.57% error, so which is really good for this particular apparatus. This is designed for a classroom application where a teacher can put this on a table and the whole class can see in a normal sized classroom. And it's great for students that are just beginning to learn the concept of force vector summation, and force vectors in general. We started by starting with the 2x4s, and we cut a notch in each. And these are cut at 45-degree angle using just a hacksaw and a miter box. These pieces here are not very critical as long as you come up with a rigid box structure. We use just a standard square wood, and commonly available from Home Depot, Ace Hardware, Lowe's. And for rigidity, to increase its structural strength, we added the L-shaped brackets in each corner, and they're screwed in, and also the whole structure is glued together, so it's very rigid. And then these are wooden dowels that you can also buy commonly at hardware stores, and ideally you want them collinear. So if this apparatus was balanced here and here, and if you put a straight bar across here, it should also be collinear to these, or parallel rather to these. And you want to get these dowels equal distance apart so that you can adjust your angles. You can vary your angles in an ideal situation. We're going to run another calculation really quick. We're looking at 35 degrees and 36 degrees. So, like I said, we're accurate to plus or minus a degree, and it usually results in about 5% error. And that's just simply due to the fact that we cannot absolutely eliminate friction from this apparatus. Ideally, if you can, you would use pulleys, but we didn't have that option due to the lack of time. But this, ideally, you want to start with a box structure that's solid with a solid base that's going to prevent it from tipping over, falling. A string with either pulleys or, in this case, we use wooden dowels that are lubricated. So, well, that's our project, and let us know what you think.